Good evening everyone. Welcome to BYJU'S Exam Prep IAS. Today onwards, for the next 3 sessions, we are going to have a discussion on science and technology and some of the key questions with regards to science and technology from current affairs of science and tech of last 1 year. Now, in these sessions, in the next 3 sessions, what we are going to discuss are some of the key areas. Now, understand this, that more than the questions that we are discussing here, the topics that are being discussed are more important. So, what I also want you to do is that whatever topics are being discussed, whatever questions are being discussed, not only the questions, but apart from that, all the analysis that we are doing, plus everything, every news that has been in one way or the other being discussed, they all have to be revised well before you go on to write the examination. So I welcome you all to these sessions on science and technology, and let's begin with the session. In today's class, there are 3 basic topics that we are going to discuss, and the questions related to these areas which have been important, which have been discussed. One is space technology. And as you know, space technology is one topic from where a lot of questions and a lot of areas are always covered in the newspapers as well. Every year you'll find that, every day when you read the newspaper, you perhaps will find something related to space technology. And that's why there are a lot of these important articles and important news items that have been there as a part of a discussion in the last 1 year. So we'll discuss things from the world of space technology. Apart from that, there are 2 more areas that we are going to cover. First is going to be the intellectual property rights. There has been one simple news with regards to intellectual property rights, so we'll discuss about that, and then after that we'll discuss a couple of questions from the world of artificial intelligence. So these are the areas that we are going to cover. So let's begin with the session. The first question. So what we'll do, I'll display the questions in front of you, go through the question, mark the answer from the poll given to you, and once you've done that, we'll have a discussion. So first question, consider the following statements about the DART mission. 1. It is NASA's first mission to demonstrate asteroid deflection by a kinetic impactor. Second statement, it was launched through NASA's Falcon 9 rocket. And third statement, it targeted the moonlet Dimorphos. Which of the above statements is or are correct? Please mark your answers and let's have a discussion on this. I'll give you just 10-15 seconds. I've already read out the statements. So I'll just give you 10-15 seconds, maybe 20. Please mark your answers and then we shall have a discussion on it. All right. As I see, most of you have marked the answer. So let's have a discussion on this. So the first statement, it is NASA's first mission to demonstrate asteroid deflection by a kinetic impactor. Now this word, kinetic impactor, whenever we are looking at the DART mission, you'll always find this word being mentioned, that is kinetic impactor. So let's try to understand first of all what this mission is. What is this DART mission? So the first thing about DART mission is that this is a mission to see whether we can deflect a given asteroid. If, let's say, in the future, sometime, if it so happens that there is an asteroid which is heading towards the Earth, do we have a technology that can deflect this asteroid from its path? And if it can, then probably we could be saved from such an impact. Because we know what this impact will do. We know about the past and we know how exactly the meteoroid impact on the Earth led to extinction of more than 85% of the species that lived back then, including the dinosaurs. So we know that such an impact could be harmful for any life form that is existing right now on the Earth. So this is what we are trying here, that we need to understand whether we have a technology in place which can deflect the asteroid from its path. And this is precisely what the DART mission is all about. So what are we doing? If you see this, you have 2 segments here. You have the Didymos and you have the Dimorphos. These are the 2 parts of this DART mission. Now when it comes to this DART mission, understand what exactly are we trying to do here. So first and foremost, when it comes to DART mission, there are 2 aspects to it. That first of all, we look at this setup where you have an asteroid which is being revolved around by a moonlet. So this is Didymos and then this is dimorphous. So we have these two. So as you can see, these are the two that we have, and through the DART mission what we are trying is that we want to deflect this moonlet. This is being called as a moonlet. Now why exactly are we calling this as a moonlet? Because generally speaking, what do we see a moon doing? We know that a moon will do what? A moon will simply go and revolve around a given planet. But in this scenario, there is no planet involved here. You have an asteroid, and then there is this moonlet, a very small celestial body which is revolving around this asteroid. So this asteroid itself is very small. It's just around 780 meters in its size. And when it comes to this moonlet, the moonlet is just 160 meters in size. So it's very, very small. And we have been trying through the DART mission. The DART mission will basically send a spacecraft towards this moonlet and try to deflect it from its path around this. And this is what we have tried, and we have succeeded in doing that. So this is what the DART mission is all about. So just let's go back. NASA's first mission to demonstrate asteroid deflection by a kinetic impactor. The word itself will give you up what exactly do we mean by this kinetic impactor. Kinetic, the word that we use often when some kind of movement is happening. When you say kinetic energy, for example, why you say kinetic energy? Because this is energy which is involved with movement. So that's why, or due to movement, that's why you call it as kinetic energy. Similarly, the second word is impactor, meaning that some kind of impact is happening here. So this is what we have been trying, that we have basically used this satellite, and this is basically moving towards, or has moved towards, dimorphous, and by doing that, this is basically what they have tried, that they are trying to collide it, make it collide with dimorphous and deflect the path of dimorphous, and this is what they have done. So this is correct. And just remember this word, kinetic impactor. If in case there is a prelims question based on that mission, the word kinetic impactor in one way or the other would often be used, would definitely be used. Alright, the second statement. The second statement is it was launched through NASA's Falcon 9 rocket. It was launched through Falcon 9 rocket, that's correct. But Falcon 9 does not belong to NASA, right? It does not belong to NASA. It belongs to SpaceX. Belongs to SpaceX, so that's why it does not belong to NASA, and hence this given statement is not correct. That's why this statement is wrong. So very often we overlook some of the statement or some of the information given in these kind of statements. So just remember that it's not only about Falcon 9, but it is not, it's something that does not belong to NASA. Alright, so that's why this is wrong. It targeted the moonlet dimorphous. This is correct. We discussed about this. So that's why this third statement is correct, and this is what we have been asked, what is correct and which are the statements which are correct. So the first and the third statements that we have here, both of these statements, they are correct. So that's why the correct answer here will be A, 1 and 3 only. Alright, so this is about question number 1, and a very, very important topic, I would say, for this year's examination. Second question. Consider the following statements about dark sky reserve. First, dark sky reserve is a tract of land with minimal interference from artificial light. Second statement, India's first dark sky reserve has been set up in Thar in Rajasthan. Third statement, NASA designates dark sky reserves around the world. So these are the three statements given. Quickly mark your answers. We are just about to launch the poll for you. And once you've done that, let's have a discussion on this question. Quickly, please start marking your answers. All right. So as I can see, most of you have marked the answer. Let's begin with the discussion now. All right. So dark sky reserve. We are talking about dark sky reserve. So what exactly do we mean by dark sky reserve? First of all, let's try to understand this. Dark sky reserve is something where we are trying to promote something called as astrotourism. Alright, we are trying to promote astrotourism through dark sky reserve. What is astrotourism? This is a place where basically we are trying to promote stargazing in a manner that where you just go and just watch the beauty of the night sky. As you can see this picture is taken from Ladakh, and this is the picture of what dark sky reserve would look like, or how the night sky would look like. Very often, I mean, most of us living in some kind of city area within the city limits, perhaps we don't get to see more than 10, 20, 30 odd stars, and that's why you don't understand how beautiful the night sky is. And these are the areas which will help you realize the beauty of the night sky, and that is what astrotourism is all about. So through this dark sky reserve, we are trying to promote astrotourism in India. Now, what do we mean by dark sky reserve? So, and how are we exactly selecting the dark sky reserve? For a place to be selected as a dark sky reserve, it should be a place which is, let's say, very away from any kind of population or any kind of source of light, any kind of pollution. You'll want to keep these kind of factors away from this kind of an area, so that you can watch the night sky very well, right? So this is basically what you would want. So that's why when it was about choosing the place in India, one of the natural choices was Hanle in Ladakh. Alright, so Hanle in Ladakh became one of the natural choices here, and that is what we have seen has been chosen as the place for creating the dark sky reserve. So why Hanle? Understand the geographical conditions and other aspects as well. First of all, Hanle is a part in Ladakh, and Ladakh, as you might already know, it's a cold desert, right? We designate it as a cold desert, meaning it's a desert area, meaning there is very little rainfall. And when it comes to an area like Hanle, we hardly see 5 days of rainfall in the entire year sometimes. So just 5 days in the entire year. And even if you just count the number of cloudless skies, you'll find that there are perhaps more than 300 days of cloudless skies in Ladakh, or in Hanle specifically. So that's why it becomes a natural choice because of these two reasons: no rainfall, no clouds. So that becomes first reason. Apart from that, this is also an area which is very sparsely populated. Hardly the population of the village is also very small, because the conditions are very harsh, the temperatures are very low, water availability is also very low, electricity connections are also sparsely present. They are largely surviving on solar energy. So because of all these reasons, what we see is that artificial light sources are almost absent, right? Artificial light sources are almost absent, and that is also the reason why India also has kept its astronomical telescope, one optical telescope, in Hanle. So India's optical telescope, also one of them, is also at Hanle. Hanle also becomes one of the areas which is very far off from any kind of population. So that's why there is minimum chances of any source of artificial light or vehicles or air pollution, anything like that. And the geographical conditions are also supporting this kind of a setup. So that's why, because of all these reasons that we have, we see that Hanle becomes a very good choice altogether, and that becomes the primary reason why Hanle in Ladakh has been chosen as the place for dark sky reserve setup in India. Alright, so let's come back to the question. Dark sky reserve is a tract of land with minimal interference from artificial land. This is precisely correct. That is the reason why we have chosen it. Second is, India's first dark sky reserve has been set up in Thar in Rajasthan. This is wrong. We just discussed that it is Hanle in Ladakh. So that's why this is wrong. So this statement is wrong. Third statement is, NASA designates dark sky reserves around the world. This is also wrong. It is not done by NASA. There is a dark sky association which basically looks after all these kind of reserves, and various different reserves that you have in the world. They actually call it as dark sky preserve. The word that often is used is dark sky preserve. And these dark sky preserves are present all across the world. Alright, but remember this: India's dark sky reserve that we are setting up in Ladakh, it's not a part of this program. It is not being done by them. It actually is being taken as an effort by the government of India. So until now they are not involved, perhaps maybe in the future, but right now they are not. So this is just something that you should remember when it comes to dark sky reserve that we are making in India, we are setting up in India rather. So that's why the third statement also is not correct. The third statement also is wrong. So second statement and third statement both are correct. Now remember, what you have been asked is which of the following statements or above statements are incorrect. You have not been asked about the correct statement, as I saw that a lot of you also marked A. Perhaps one of the reasons could be this also, that you did not see that you have been asked to mark something which is incorrect rather than being correct. So that's why second and the third statements are incorrect. So our answer here will be 2 and 3 only. Alright, so question number 2, the correct answer is C, that is 2 and 3 only. Moving on, the next question. Question number 3. With reference to India's satellite launch vehicles, consider the following statements. First, ISRO's next-gen launch vehicle NGLV will replace PSLV. While satellites launched by GSLV are used for communication, NGLV will be used for both communication satellites and human space flights. NGLV will be able to carry a workload of 20 tons to geostationary transfer orbit. So these are the 3 statements that have been given to you. Please look at the questions, mark your answers, and let's have a discussion on this as well. All right. Fine. So let's start with the discussion on this. NGLV, Next Generation Launch Vehicle. Now first and foremost, understand the requirement, that why exactly are we looking for NGLV? What is the basic problem that we are facing right now? Currently, you might know that there are 2 basic launch vehicles that we use. One is PSLV and the other one is GSLV, right? So these are the 2 that we have been using currently. PSLVs often will be used for lighter satellites. Generally, you will see that the satellites that you have up to 1500 kg, they'll be launched using PSLV. And then the ones which are heavier than this, you'll find that they'll be launched using GSLV. So very often you'll find that the ones that are up to 4000 kg communication satellites, they will be launched using GSLVs. So this is what we see currently. Now the problem is that there are communication satellites that we very often launch which weigh more than 4000 kg. For example, a couple of the ones that have been done in 2021, 22, etc., you'll find that they weigh more than 5000 kg, in one case more than 5500 kg. So that's why we are not capable of launching these kind of heavy satellites. So then we have to take the help of some of the other space agencies. For example, we very often go to France, and France launches some of these communication satellites for us. For example, France has a launch vehicle called as Ariane 5. We very often use Ariane 5 to get our launches done for the heavier satellites, the ones where we are not capable. Alright, so this is where we see that NGLV comes into the picture, that whether it's a light satellite, whether it's a heavy satellite, we will have one launch vehicle which will retire the launch vehicles of the present day, and it will replace all the launch vehicles. Now what was discussed, where does the discussion start from? The very first discussion that you will see was last year when there was one seminar that was being conducted. This is where ISRO officials were also there, and ISRO chairman there, he spoke about this, that we are now going to construct a next generation launch vehicle, and this next generation launch vehicle is going to replace the present or the operational PSLVs and GSLVs also in the future. So that's why he spoke about it replacing PSLV. And at the same time, what he said is that this is a launch vehicle that is going to have a much heavier capacity, and the capacity that he had spoken of was up to 10 tons. Up to 10 tons, meaning we are talking about 10,000 kg to the geosynchronous transfer orbit. Alright, so this is basically what he had spoken about. So 10,000 kg or 10 tons. Here the question, the statement says 20 tons. So that's why this is wrong, because he spoke about 10 tons. Alright, so this is basically what we have seen. So this is correct because it is going to replace PSLVs along with the other launch vehicles as well. So yes, it will replace PSLV. Now the second statement could be a little tricky. So try to just understand what this statement says. While satellites launched by GSLVs are used for communication, NGLV will be used both for communication satellites and human space flights. Now here, what about the Gaganyaan mission? In the Gaganyaan mission, what are we doing? We are going to use GSLV Mark III, right? We are going to use GSLV Mark III for the Gaganyaan mission, which is a human space flight. So that's why something that they are also calling as launch vehicle Mark III nowadays. So launch vehicle Mark III or GSLV Mark III, they basically are the two names of the same launch vehicle. So for Gaganyaan mission, we are going to use that. So while satellites launched by GSLV are used for communication, they are not being used for only communication. They are also being used for the Gaganyaan mission, which is a human space flight. So that's why we cannot say that it is only being used for communication. So that's why from that perspective, I would say that the second statement also is wrong. So that's why it becomes a little confusing statement for you, just to understand and try to get the meaning out of it. So I would say only the first statement is perfectly correct. So the correct answer here should be 1 only. So I know that many of you marked a wrong answer because there could be some confusion in your mind. So that's why this is how we have to look at these kind of questions. Moving on, the fourth question. Consider the following statements about James Webb telescope. First, it is an ultraviolet observatory orbiting around the sun. Second, it will study the formation of earliest galaxies. Alright, so these are the two statements given to you. So look at the statements, mark the options. We are just launching the poll for you, and then we shall have a discussion on it. This is an easier question, so I expect a better number of correct answers here. Alright, so as I see, many of you have already marked the answer. Let's have a discussion on it. So we are talking about James Webb Space Telescope. Now, when it comes to James Webb Space Telescope, first of all, you might know that after a lot of delays in the launch, ultimately on 25th of December 2021, the launch of James Webb Space Telescope was done. And it has been said to be a successor of the Hubble Space Telescope, right? So it is being seen as a successor of Hubble Space Telescope. Now, some of the key important points when it comes to the James Webb Space Telescope. First of all, when we say the successor, meaning that now ultimately Hubble Space Telescope is going to be retired and James Webb Space Telescope is going to be the space telescope for the world. Apart from that, there are a couple of new changes or new you can say things that have been introduced into James Webb Space Telescope to make it one of the most effective of all the space telescopes that we have seen until now. First of all, when it comes to James Webb Space Telescope, we know that when it comes to it, it is going to do its analysis, it is going to do its studies in the infrared region. Alright, it is going to do its studies in the infrared region. So when we say infrared, what is infrared? Infrared is one of the electromagnetic waves, right? And it is an electromagnetic wave which has a longer wavelength. Alright, so it has a longer wavelength. So it has a longer wavelength altogether. So longer collected to, compared to what? Longer compared to the Hubble Space Telescope, because Hubble Space Telescope works in the visible part of the electromagnetic spectrum. So it uses the visible light. It uses the visible light, the light that we also perceive, our eyes also perceive, the same light. Now, visible light, just understand this, that visible light has a smaller wavelength, a shorter wavelength, and because it has a shorter wavelength, it cannot take observations from very far away. So to do that, to make that happen, to make this modification, or what we have done is that this time we wanted to use the infrared rays, because infrared rays are longer in their wavelength, and because they are longer in their wavelength, they can travel longer distances, so hence they can catch the signals coming from very far off galaxies and very far off celestial bodies. So that becomes one of the very key important areas when it comes to some of the improvements that have been introduced on the James Webb Space Telescope. So that becomes one of the most important points. So that's why that becomes one. Secondly, always remember, this is also a point which is very often being discussed when it comes to James Webb, and this is the point that this is being kept at L2, meaning that Lagrange point 2. This is being kept at Lagrange point 2. Now Lagrange point 2, or Lagrange points in general also, last couple of years they have been in the news very often, and in the newspapers, in the articles also, they have discussed about what Lagrange points are. So there are chances, and I have been saying this for perhaps the last 3 years, that there are chances that they might ask you a question based on Lagrange points. So that's why just remember the basic have a basic understanding of what we mean by Lagrange points. Alright, so Lagrange points, just remember that these are very special points wherever you have a two-body system where one body is revolving around another body. So in these kind of systems, you'll find that there are 5 special points that are often created, and these 5 points are called as Lagrange points. One of those Lagrange points is Lagrange point 2, and this Lagrange point 2 is special. That why exactly, understand this, that why exactly did we choose Lagrange point 2? Because before this, when it comes to the Hubble Space Telescope was kept in the low Earth orbit, meaning it was in the near Earth orbit. But compared to that, James Webb Space Telescope has been kept away from there, and it has been kept at L2. Now, the basic property about L2 is that L2 is a point which is situated in a region which is in the shadow region of the Earth. What does it mean? It means that it is always protected from the radiations of the sun. It lies in the shadow region of the Earth. So if this is the sun, let's say if this is the Earth, then L2 basically lies here. So that's why the sun's rays, they do not reach L2. So that's why L2 becomes a point which is protected from the radiations of the Earth. And that is why it has been kept at L2, because when you have to take observations of the outer space, you would want that all the sensitive machinery that you have on board, they should be functional, and they should not come in contact with anything, any radiation that can be harmful for them. And in the presence of a lot of radiations coming from the sun, it would make it even more difficult for such a telescope to take its observations. And when you want to make observations of very far off galaxies and very far off celestial bodies, then in that case you will always have to try and shield it from the radiations of the sun. And that is precisely the reason why L2 was chosen. So this is what we see. Now look at what the question says. First statement, it is an ultraviolet observatory orbiting around the sun. It is not ultraviolet. What is it? It is infrared, right? This is wrong. It is infrared. So that's why the first statement is not correct. The second statement, it will study the formation of the earliest galaxies. This is precisely correct. This is one of the objectives that has been taken for the James Webb Space Telescope, that they want to study the earliest universe that was, or earliest galaxies that were formed after the birth of the universe. So that's why the second statement is correct. The first statement is not correct. You have been asked what exactly is correct, so the answer will be B. that is 2 only. So this is what is correct. Alright. So let's move on. Question number 5. With reference to Navik, consider the following statements. First statement, Navik is a regional navigation system which provides navigation within the territorial boundary of India only. Second statement, Navik is a constellation of 7 satellites, 3 placed in geostationary orbit and 4 placed in geosynchronous orbit. Third statement, it is the world's second navigation system after global positioning system. Alright, just remember that you already here also you have been asked what is incorrect. So we are launching the poll for you. Mark your answers and let's have a discussion on this. Alright, so as I see most of you have marked your answers, so let's have a discussion on this. So the first statement says Navik is a regional navigational system which provides navigation within the territorial boundaries of India only. Now first of all, whenever you see these kind of words in the classroom also, sometimes I've said this, that whenever you find these kind of extreme words, always beware, and they very often are wrong. So only. Now understand this, that Navik, or what you also call as Indian Regional Navigation Satellite System or IRNSS, this is a satellite system, a navigation satellite system that has been launched by India, and this is a system that is going to act as the navigation and positioning service provider for India, and not only within the Indian boundaries but also up to 1500 kilometers beyond the Indian boundaries. So that's why it's not only within the territorial boundary of India, it's Indian boundary plus 1500 kilometers beyond the Indian borders as well. Mainly also to take into account the Indian Ocean region. That was the main purpose here. So up to 1500 kilometers beyond the Indian borders is what it is going to cover, and not only within the Indian boundaries. So that's why this is something which is not correct. So this is wrong. Second statement, Navik is a constellation of 7 satellites, 3 placed in geostationary orbit and 4 placed in geosynchronous orbit. Now this is correct, because if you look at the basic setup, what you see is that this is how you have a set of 7 satellites. So these 3 are geostationary satellites. Alright, this is geostationary 1, this is geostationary 2, and this is geostationary 3. So these are the 3 geostationary satellites, and then you have the 4 geosynchronous satellites. So this is also correct. So this is how the setup is. Alright, so these 7 satellites together, they are going to provide the positional and the navigational services in India. So that's why this is correct. The third statement, it is the world's second navigation system after global positioning system. Now saying second on what basis? First of all, there are many others. For example, China has its own BeiDou, Russia has its own GLONASS, then Europe has its own Galileo, similarly Japan also, India. So there are so many countries here who have their own navigation system. So it's not that India is the only country or India is the second country after GPS. Alright, so that's why there are all these countries also. So you cannot say India is only the second, or in any way you cannot say India is the second. So that's why this statement also is not correct. So that's why the only correct statement is the second statement. You have been asked what is incorrect. So incorrect is statement number 1 and 3. Now understand why a question on Navik. Last 10 years Navik or IRNSS has been in the news, and we have seen already a couple of questions that have come from here. Now, why again has it come back in the news? Because now what we have seen is that there has been a suggestion and also some kind of push from the government of India towards the a lot of mobile phone companies, that they should now start adopting IRNSs. Some of the mobile phone companies already have done that. They already have started adopting it, but there are other companies which have not started adopting it, and the government of India has requested these companies also that they should also start adopting IRNSs, and they should move away from GPS based navigation, because for some of the companies they are still based completely on GPS, and they are providing all the navigation and the positioning services in India based on GPS only. And that's why they have been asked, they have been suggested that they should start moving towards IRNSS based systems. So that becomes one of the reasons that why exactly has it come back in the news, because now we see that there is a push towards adoption, and government of India is trying that wherever possible, wherever the navigation and the positioning services are required in India, they all should start moving towards IRNSS. They have also been able to improve upon the accuracy of IRNSS with the help of the atomic clocks that we have on board. So we have these atomic clocks. Now just understand this, that when it comes to atomic clocks, these atomic clocks, they are very precise, they are very accurate clocks. They are much more precise than the normal clocks that we are using, and because you are using something like this for a navigation system, you definitely need to be as accurate as possible, and that's why these atomic clocks there become very, very important. And we see that there are cesium based clocks, for example, which are used very often in these kind of cases. So to provide this precision, we see that these clocks are used, and we have seen that the precision has been able to improve. We have been able to see an improvement in the accuracy of IRNSS as well. So because of these reasons, now we see that there are some areas where we have been improving. Technically, we have now a much improved version of IRNSS, and that also becomes one of the reasons why exactly it has been in the news. So that's why when it comes to this, remember that this question or this topic can again become important for your examination. Let's move on. Question number 6. So question number 6 says NASA's Artemis mission is related to the exploration of. So one is deep space, second is moon, third is sun, and the fourth is galaxies. So we are launching the poll for you. So please mark your answers and let's have a discussion on this particular question. Alright, so as I see, most of you have marked the answer, and most of you have marked the answer correctly. So NASA's Artemis mission is basically related to the exploration of the moon. That's perfectly correct. Now understand again why exactly has it been in the news. And again, it has been in the news for again last couple of years now. So this time it is also in the news because of the names of the astronauts that have been released. That who are the astronauts who are going to be a part of the Artemis 2 mission. So there is the Artemis 1 mission. There is the Artemis 1 mission, and then now there is the plan for the Artemis 2 mission. Now Artemis 1 basically is an unmanned mission, alright. This is an unmanned mission which is, you can say, more of a technological demonstration where we are trying to understand the technology, where we are trying to see and understand the safety and the security of the mission, because ultimately the second mission, Artemis 2, is going to be a human space flight where they are going to carry these 4 astronauts to the moon, alright. So 4 astronauts are being carried to the moon, alright. 4 astronauts are being carried to the moon. So now, 4 astronauts are being carried to the moon, and these 4 astronauts, basically what they want as a part of the Artemis mission is that they'll keep on improving upon the complexity of the mission, and there will be a series of missions that will be sent one after the other. So it's not that there are only 2 missions that are involved here. This is going to be a series of missions, and this series of missions basically will be mission that is going to the moon. Now, also understand why exactly has it been in the news, because the 4 astronauts who have been chosen, they, first of all, one of the astronauts is a woman. So for the first time, a woman will also be a part of the crew that is going to the moon. That is one. Second, the second astronaut who has been chosen is a person of color, that for the first time a non-white has been chosen to go on the moon. So that's why a person of color has been chosen, a woman has been chosen, and a non-American citizen has been chosen. The third astronaut also comes from the Canadian Space Agency, a part of Canada. So that's why for the first time NASA is also going to send an astronaut who is of non-American origin. So that's why this is basically what we have seen, and that is the reason why as soon as the names of the astronauts and the story of the astronauts were released, it all again came back in the news, and that's why Artemis mission has been in the news. So for the first time, because Artemis 1 mission was launched, which is an unmanned mission to the moon, and then after that the announcement of the second mission happened. So initially the second mission, Artemis 2, was actually supposed to happen in 2023 itself, but very recently, just a couple of months back, it was announced that now this is being pushed to November 2024. So now this mission will be launched in November 2024. So first mission in 2022 and the second mission in 2024. And this is what the plan is when it comes to the Artemis mission. So they will keep on increasing the complexity of the mission one after the other, and they'll keep sending all the astronauts one by one onto the moon. This is what the plan is. So that's why Artemis mission is related to the moon. This is what the correct answer is. So remember that when it comes to the astronauts, you have a person of color, a woman, and a non-American citizen. So that is why this also was in the news. Alright, so let's move on. The next question. Question number 7. Consider the following statements about Event Horizon Telescope. First, it is an array of 10 radio observatories around the globe, creating a telescope within an aperture equal to the size of the Earth. Second, EHT focuses on the study of black holes. Third, event horizon is the point in space where even light cannot escape the gravitational force of a black hole. These are the 3 statements given. So please mark your answer now. We are launching the poll for you, and then we shall have the discussion here. Alright, so let's have a discussion now. I see most of you have marked the answer now. So the 3 statements. The first statement is, so first and foremost, what is this Event Horizon Telescope? Alright, so Event Horizon Telescope, as you can see here, it's a set of telescopes that have been placed all across the world. Right, they have been placed all across the world in a manner that they'll be doing all the analysis and they'll be trying to study black holes. So that's why what exactly this Event Horizon Telescope is. This is a telescope to study black holes, to take the pictures of the black hole. Now why exactly has it been in the news? Again, Event Horizon Telescope for the last 3-4 years often has been in the news. The very first time that it was in the news was in 2019, because in 2019 it was able to take the first picture of a black hole. First picture of a black hole was taken with the help of this Event Horizon Telescope, which brought it in the news. And then they also improved upon this picture. They got a better picture of the same black hole, and then after that the first black hole that they had taken the picture of was called as M87, called as Messier. M is for Messier, 87 star. So this was basically the first picture of a black hole that was taken, and now this is something that was again back in the news, because this time they also took the picture of Sagittarius A star, which is a black hole in the middle or at the center of the Milky Way. Center of the Milky Way galaxy. And that's the reason why it has been back in the news, that it has now taken the picture of Sagittarius A star, which is at the center of the Milky Way galaxy, in our own Milky Way galaxy. So M87 is not a part of it. So that's why this time we see that this was a big important observation, and that's why it has been back in the news. Now when it comes to Event Horizon Telescope, just understand what exactly are they trying to achieve with the help of this telescope. So when it comes to Event Horizon Telescope, this is a set of telescopes, a set of, if you count here, a set of 8 telescopes. So as you can see here, 4 plus 4, 8. This is where this is wrong. I know this is a kind of a factual question that we have thrown at you, but sometimes it can happen to you in the prelims examination also. So that's why. Alright, so it is not 10 but rather a set of 8 telescopes. Alright, now you don't need to know the names, you don't need to remember what the names of these telescopes are, they would never ask you that. So that's why don't be bothered about the names of the telescopes, just remember that it's a set of 8 such telescopes. Now why 8 such telescopes? Understand one basic problem, that when we are talking about black holes, alright, when we are talking about black holes, what exactly is a black hole? You might know this, that black hole is just a region in space where the gravitational pull of that region is so strong that even the light particles cannot escape that region, right? This is what black hole is. So now what happens here is that because of that, every particle, every celestial body, whatever is there in that region, in and around that region, they will basically be pulled towards the center of this black hole. This is what happens. And even light particles, when we say that even light cannot escape, so here what we see is that light basically is also made of photons, or which are light particles, and these light particles, they are not able to escape. They are not able to escape because of a very strong gravitational pull of the center of this black hole. So now what happens, because light particles have been pulled towards the center of the black hole, because of that there is kind of an absence of light, and because there is absence of light, you can't see anything. So because you can't see anything, it becomes a region which is completely dark, and that's why we call it as a black hole. And how do we understand that a black hole exists in such a given region? The basic idea behind this is that the basic hint that we get is from the kind of activity that happens around this region, that you find that, let's say, when we are looking at a black hole or towards a black hole with the help of our optical telescopes, what we might see is that this is a place which is completely dark and surrounded by areas where you see a lot of activity where some of these celestial bodies are moving towards a central region which is completely dark. That gives a hint that there might be a presence of a black hole in such a region, and that is where we get a hint about the presence of a black hole. Alright, so we know this. So because of absence of light, how can we take a picture? Because what you need basically to take any picture, any photograph, is light. So if, let's say, there is no light, you can't take a picture. So that is the basic problem that we are facing. Now to take picture in an area where you have very little light, let's say you have very little light, what do you do in such cases? You will have to increase the aperture. Aperture is basically the opening. In a camera also, you might see that today there are many mobile phones which have night mode cameras and all that. Apart from using artificial intelligence, what they also use is a bigger aperture. Aperture meaning a bigger opening. So if there is a bigger opening, it means that it can let more light come into the opening of this camera. So more light can enter, and if more light can enter, there are higher chances that you'll be able to take a photograph. So this is basically what is happening in such a case. Now when it comes to this aperture, one of the basic problems is that, let's say, if you are using one single telescope, alright, just one telescope, then this one telescope will have its own single aperture, which perhaps will not be big enough for us to capture light from an area where there is kind of an absence of light, which is black hole, right? So that's why a single telescope perhaps will not be helpful for you. So what will you do now? Now what we do here is, this is what the scientists thought, that let's combine the forces of all these telescopes placed all across the world so that they can in a combined form increase their aperture to the size of the Earth itself. This is what they have been trying through this Event Horizon Telescope program. That's why Event Horizon Telescope is not one single telescope but an array of 8 separate telescopes which have been placed in different parts of the world. So first statement, it is an array of 8 radio observatories around the globe creating a telescope with an aperture equal to the size of the Earth. So this part is correct, but the 10 part is not correct. So first statement is wrong. Second, it focuses on the study of black holes. This is precisely correct. This is what we have been trying. We want to focus on the study of the black holes in a manner that we are able to capture the images of black hole. So this is what the Event Horizon Telescope is all about. And the third statement is about event horizon itself. Event horizon is the point in space where event light cannot escape the gravitational force of a black hole. Now this is correct. The reason why it has been named as Event Horizon Telescope is that because it is trying to capture the event horizon of the black hole. Alright, it basically captures event horizon of the black hole. This is what we have been trying through the Event Horizon Telescope. Now what is this event horizon? Event horizon is nothing but the boundary of a black hole. Alright, it's simply the boundary of a black hole. So what we simply mean is that just like a well, alright, so what happens in a well, that let's say if there is a boundary of the well like this, if somebody crosses this boundary, if any one of you, please don't do that, but if any one of you cross the boundary of this well, what happens? You fall into the well. Why? Because you are falling towards the gravity. Same happens here also, that the center of the black hole will be very strong with its gravitational force, and because it is very strong with its gravitational force, what happens next is that in this case, anything that crosses this event horizon, any particle, any object, any celestial body that crosses the event horizon of a black hole will fall towards the center of the black hole. The center of the black hole, which is also called as singularity. If you have heard of this term, singularity. So it simply falls towards singularity, it falls towards the center of this black hole if it crosses the event horizon. Alright, so this is what is happening here. So event horizon is that point in space where even light cannot escape the gravitational force of a black hole. This is correct, that this is the point in space after which you'll see that everything will be pulled towards the center of the black hole. So that's why second and the third statements are correct. So correct answer here will be B, that is 2 and 3 only. Alright, moving on. Question number 8. Lux Zeppelin recently in the news is related to. 4 options in front of you: dark matter, subatomic particles, large hadron collider, and gravitational waves. Please mark your answers. We have launched the poll for you, and let's have a discussion on it. All right. So as I see, most of you have marked your answers. So let's have a discussion. Let's begin the discussion. So Lux Zeppelin, alright, recently in the news is related to what? The straightforward answer is it is related to dark matter. Now how exactly is it related to dark matter? There are 2 things that you have to understand here. Now first of all, when it comes to again trying to analyze your prelims examination and how a question might perhaps come from here, first of all, dark matter is back in news. Alright, has been in the news on and off. It's not that it hasn't been in the news, but it's back in the news because of the experiment that is being done through this particular experiment. So what exactly are we trying to do? First and foremost, we'll try to understand what is dark matter. There are 2 concepts here for you. One, what do we mean by dark matter? I'm sure many of you know, but I'll still explain it. And the second is, what do we mean by weakly interacting massive particles? Alright, weakly interacting massive particles. So these are two things that we need to understand here. That first of all, what do we mean by dark matter? Now understand what dark matter is. When it comes to the composition of the universe, you might see a lot of things, you might know about a lot of things, but unfortunately whatever you know of, whatever you have seen around is a very tiny fraction of whatever exists in this universe. 95% of the universe is something that is unobservable for us, is something that we don't understand at all. Alright, 95% of the universe is something that we don't understand. What is this 95%? Out of this 95%, 68% is something called as dark energy, and then 27% is something called as dark matter. 27%. Now why do we call dark energy and dark matter as dark? It's not because of it's related to some kind of dark forces that the movies show us, or it's not because of some kind of darkness that they have in them, but the name dark has been given, the term dark is being used here because we are in the darkness. Because we don't know what it is. We just understand that they must exist, we just understand they do exist, but we don't know what they are. And because we don't know what they are, because we have no idea about what they are, we have conveniently named them as dark energy and dark matter. So here when it comes to dark matter, what do we mean by dark matter? Dark matter basically is that form of matter that exists in the universe, but we don't observe them. We haven't been able to observe them yet. Alright, yet being a very important word. So we haven't been able to see them or observe them yet. We understand about their presence from our calculations. Alright, our calculations show us that they must exist, but we still don't understand how, in what form, and that is where the problem lies. So when it comes to dark matter, we are saying that almost 80 to 85% of all the matter that we have in the universe is dark matter. And the matter that you see, what is matter? Class 6 science books will tell you anything that has mass and occupies space is called as matter, right? So this also is occupying space, this also has mass, but you can't see it. Alright, you can't see it, you can't observe it, and this is where the problem lies. So it's just like that if let's say you are sitting in a room right now and you have a lot of things around you, let's say table, desk, chairs, books, maybe your bed, maybe everything else. So you have all these things in your room. If you weigh everything together, you take everything on a weighing machine and you weigh everything, you just find that okay fine, it is around individually when you have done it, maybe it has weighed around 1000 kg. And then you pick up the room as a whole. You have, remember, all the bricks and cement etc. also have been weighed, all came out to be 1000 kg. Now you pick up the room as a whole and you find the weight to be 2500 kg, and you don't understand where this extra weight is coming from. So it shows that there is something else in the room which you cannot see, which you cannot observe, but is sitting right next to you watching the session. And something similar is happening in the universe as well, that in the universe also there are a lot of things that we can't see, there are a lot of matter that we can't observe, just that we know about their presence. Our calculations show that they must be present, and that is basically what we have seen as, that we have named it as dark matter. Alright, this is what we have named as dark matter, the unknown form of matter that exists in the entire universe but can't be observed is dark matter. Now what is this? This is called as weakly interacting massive particles. Weakly interacting massive particles. Alright, weakly interacting massive particles. What do we mean by them? Now, weakly interacting massive particles basically are hypothetical particles. Remember this, hypothetical. They are not actual particles, they are hypothetical particles, which are supposed to be the strongest candidate for being named as dark matter. Alright, they are the strongest candidate for being named as dark matter because there have been some instances, there have been some experiments, some thoughts behind it which are proving that perhaps this is what it is, perhaps this is the missing part, and this is what they have been trying to detect through this particular experiment. They are trying to detect the weakly interacting massive particles, and if they are able to detect them, if they are able to detect these particles, they perhaps will name them as dark matter. So this is why this experiment is very, very important. Weakly interacting massive particles. Now understand why weakly interacting, why massive particles. Weakly interacting mainly because they are interacting with the help of weak nuclear forces. Alright, there are weak nuclear forces behind the interaction of these particles and hence weakly interacting. Why massive? Massive because they are thought to be having a mass which is higher than the mass of a proton. So massive does not mean massive as in bulky or they have very huge mass. No, they are bulkier than a proton. That's it. They are bulkier than a proton and hence they have been named as massive particles. Alright, so that's why weakly interacting massive particles. So weakly interacting massive particles, they are the strongest candidates to be named as dark matter if at all we are successfully able to detect them, we are able to find them in larger quantities. So that's why remember this word weakly interacting massive particles or WIMPs. So they are all related to dark matter. So this is about this question. Remember these two concepts, very important for your examination. Moving on. Question number 9. Consider the following statements about Chandrayaan-3 mission. First, it will only consist of a lander which has crashed during Chandrayaan-2 mission. Second statement, Chandrayaan-3 will be launched through GSLV Mark III. So these are the two statements given in front of you. We are launching the poll for you. Please mark your answers, and once you have marked the answer, then we shall have a discussion on it. So please mark your answers. All right. So as I see, many of you have already marked the answer. Let's have a discussion. Let's begin the discussion here. Consider the following statements about the Chandrayaan-3 mission. Now Chandrayaan-3. To understand what Chandrayaan-3 is, first we have to go back to Chandrayaan-2 mission. Now Chandrayaan-2 mission, as you might know, was partially successful. It was not completely successful. There were three major parts of this Chandrayaan-2 mission. One was an orbiter, second was a lander, third was a rover. Alright, these were the three parts. There was an orbiter, there was a lander, and then there was a rover. Right, so these were the three parts of this Chandrayaan-2 mission, out of which the orbiter part was successful and these two were not successful. Alright, lander and the rover, they were not successful. What happened? Just about the time when they were about to just launch, land on the surface of the moon, that is where they lost the contact with the Earth station and they crash landed on the surface of moon, and this is where we see that this was a part which could not be success. Orbiter was. Now understand first of all, what do we mean by an orbiter, lander and rover? Orbiter is something which is supposed to orbit, right? So for example, the Mangalyaan mission is also called as the Mars orbiter mission. Why do we call it as Mars orbiter mission? Because it is orbiting around Mars. So that's why Mars orbiter mission. Similarly, here also we had an orbiter which is still functional, which was the successful part. And then we had a lander. What is the role of a lander? Lander is supposed to land, that it will just land on the surface of any given celestial body. So here also this was what was supposed to happen. There was the lander named as Vikram. There was this lander named as Vikram, and this was supposed to land on the surface of the moon, but it did not land properly, it crash landed. And then the rover. Rover is something that is supposed to roam around, alright, which is supposed to go on a walk on the given surface of the celestial body. And the name of the rover was what? It was Pragya. So Pragya rover and Vikram lander. These were the two parts which were not successful. Now, when it was not successful, this is where the announcement of Chandrayaan-3 came. That Chandrayaan-3 is going to again retarget the same. It is trying to re-attempt what was not successful in Chandrayaan-2. The lander and the rover will be sent back. the lander and the rover will be sent back to the moon, and this is what Chandrayaan 3 mission is. So look at the first statement now. The first statement says it will only consist of a lander which has crashed during Chandrayaan 2 mission. Now first of all, whenever you find this word only, always understand that there are high chances that this is a wrong statement. So it is not only the lander, but it's lander and the rover. Both are going to be sent. Alright, both are going to be sent as a part of the Chandrayaan 3 mission. So that's why the first statement is not correct. Chandrayaan 3 will be launched through GSLV Mark 3. This is correct. Even Chandrayaan 2 was launched with the help of GSLV Mark 3. The same is going to be the case with Chandrayaan 3 as well. That here also we are going to use GSLV Mark 3 to launch Chandrayaan 3. So first statement is wrong, second is correct. You have been asked what is correct, so correct answer here will be B, that is 2 only. Now understand this, one thing that you must note. No question came from Chandrayaan 2. Alright, it was expected that they would ask a question from Chandrayaan 2, but they did not. Now that Chandrayaan 3 is in news, there are chances that instead of asking anything from Chandrayaan 3, which has a very limited scope of any question being asked, not launched yet, there are chances that they'll go back to Chandrayaan 2 and perhaps ask a question based on Chandrayaan 2. Alright, so that's why it becomes very, very crucial from the perspective of your examination that you don't just look at Chandrayaan 3 as a mission because Chandrayaan 3 has been in the news, but also because Chandrayaan 2 has been missed. One of the biggest news of the time was not asked by UPSC in the prelims examination. So chances are that they'll revisit the topic, and that's why there are chances that they'll come back and question perhaps will be asked. So because last 2-3 years I've been saying the same thing, but the question hasn't come, but still expecting that a question would come. If not Chandrayaan 3, then Chandrayaan 2. Right, moving on. Question number 10. With reference to Aditya L1, consider the following statements. First, it is India's first space-based observatory. Second, as against earlier solar mission, which focused on sun's corona only, Aditya L1 will focus on the chromosphere, photosphere and other emissions too. Third statement, it will be launched through PSLV. So 3 statements given here. Remember, you have been asked what is not correct. So please mark your answers and let's have a discussion on this. Alright, so as I see many of you have already marked the answer, so let's start the discussion here. With reference to Aditya L1, consider the following statements. So first and foremost we are talking about the Aditya L1 mission. Now Aditya L1 mission, what is it about? It basically is ISRO's mission to study the sun. Alright, it's ISRO's mission to study the sun. Why exactly has it been named as Aditya L1? Because it is being launched to L1. It is being launched to this part, which is again a Lagrange point. Another Lagrange point. So we discussed about one Lagrange point, that is Lagrange point 2, and here we are talking about Lagrange point 1. What is special about Lagrange point 1? The speciality about Lagrange point 1 is that it is basically on the straight line that joins the sun and the earth. The straight line that joins the sun and the earth, L1 is placed between it. Alright, L1 is placed between the sun and the earth on this straight line that joins the sun and the earth. And that's why the movement of L1 also happens along with the movement of the earth. So as the earth revolves around the sun, L1 also takes its own course like this. So that's why it will also keep on revolving around the sun just with the earth. So it will always lie on that straight line that joins the sun and the earth. So when we are launching this mission to L1, what exactly is the importance of it, and what exactly are we gaining out of it? Understand this, because L1 is directly between the sun and the earth, it will always keep facing the sun. right? It will always keep facing the sun, and that's why it becomes a great point to study the sun, because you will always be facing the sun. If let's say it was a normal orbit, then in that normal orbit it would keep coming, keep going behind the earth, keep coming in the front, keep going behind, and so on. So that's why it cannot take seamless study or seamless data from the sun. So to take that seamless data from the sun, L1 is the point where you want to go, and that is precisely what we have been trying. So this is what we are doing with the help of the Aditya L1 mission. Now understand this Aditya L1 mission. The first statement says India's first space-based observatory. Is it India's first? It is not. Why? Because there has been this Astrosat, and I have a question for you on Astrosat as well. But we have this Astrosat, and this Astrosat is the mission which can be called as the first such mission by India, which can be called as India's first space observatory. So that's why Aditya L1 cannot be called as India's first observatory, because Astrosat is that, because it was launched in 2015 and became India's first such observatory. Alright, so first statement is not correct. The second statement, as against the earlier solar mission which was focused on sun's corona only, Aditya L1 will focus on the chromosphere, protosphere and other emissions too. Understand this. Many a times, why I have given this? First of all, this is wrong, because there is no earlier solar mission. Alright, there is no earlier solar mission. This is the first solar mission that India is taking. Now why this story? Many a times you will find that UPSC will make very wonderful stories around some fake information, where it has nothing to do with anything, just that it seems like a believable story. Many a times it does happen that there will be a believable story that they'll put forward in front of you, something that has been very accurately curated in a manner that it looks believable. And many a times what happens is that we fall into a trap in these kind of statements. So that's why just understand this, that it's not always something that looks to be correct. It's not that it will always be correct. You always have to look into the merits and the demerits of the statement, understand the statement. If you find it to be correct, if you know something about it, fine. So always go with the merit of the statement. Don't try to give into the story and not try to believe into the story because you've not heard of it. So that's why this is a wrong statement. There is no earlier solar mission, and that's why there is no other observation that we have done with the help of any other solar mission in India. The third statement says it will be launched through PSLV. This is correct. The PSLV XL will be the version that will be used to launch Aditya L1 mission. So that's a PSLV XL will be used. So this is correct, that it will be launched with the help of PSLV. So third statement is correct. First and second are not correct. So this is what you have been asked. You have been asked the statements which are not correct. So the correct answer here will be 1 and 2 only. These are the statements which are not correct. Precisely when it comes to Aditya L1, the most important job of Aditya L1, the most important objective of Aditya L1 will be to study the sun's atmosphere, because there are a lot of activities that happen in the atmosphere, and there are some of these activities that we still don't understand well. So we want to understand them better. We want to increase our understanding about the sun's atmosphere, and that becomes one of the primary objectives when it comes to the Aditya L1 mission. So this is what we are trying to do with this particular mission. All right, moving on. The next question. Question number 11. Consider the following statements regarding Astrosat. 1. It can make multiple observations in the wavelength range of ultraviolet to gamma rays. Second, it orbits in near Earth orbit. Which of the above statements is or are correct? Alright, so we are launching the poll for you. Please mark your answers and let's have a discussion on this question. Alright, so as I see, most of you have marked the answer, so let's have a discussion on it. So first and foremost, Astrosat. Why Astrosat? Astrosat completed its 5 years, alright. It was supposed to be launched, it was supposed to be functional for 5 years between 2015 to 2020. But it has been functional even after that, and because of that it has often been in the news, and last year also because of some of the new observations that it made, it was again back in news. So first and foremost, when it comes to Astrosat, what is this Astrosat? We say that Astrosat is a multi-wavelength observatory. Alright, multi-wavelength observatory, where multi-wavelength meaning what? That multiple wavelengths are being used here in this particular observatory. So when it comes to the multi-wavelength observatory, what we see is that the wavelength range, what we see here is ultraviolet to gamma, meaning that ultraviolet rays, X-rays and gamma rays, these three are being used. Alright, these three are being used in the study that is being done by Astrosat. Now when it comes to these three, so that's why this is correct, that this is the part of the electromagnetic spectrum that we are trying to use. Basically what we are trying to use are the shorter wavelengths. We are trying to use the shorter wavelengths here, and the longer ones often are used. For example, we have so many observatories that are based on the optical light or the larger wavelengths, longer wavelengths, but this time we are trying to do the analysis of the shorter wavelengths. So that's why Astrosat has been famous for that, and it orbits in the near Earth orbit. This is also correct. Near Earth orbit, something that we also call as low Earth orbit. So this is correct, that it has been placed in the low Earth orbit, and it was, I think, in the range of almost 650 kilometers above the surface of the Earth is where it was kept. So in the low Earth orbit it was kept, and this is what Astrosat has been. So both the statements, that's why both the statements that have been given here in the context of Astrosat, both of them are correct. So that's why remember that it is India's first multi-wavelength observatory. Alright, India's first multi-wavelength observatory, where the shorter wavelengths is what we are trying to make the observations in. And over the last 7-8 years that it has been functional, we have seen that it has been able to observe a lot of things which were unknown. A lot of new discoveries have been made, which was also unknown before that. So for example, one of the key discoveries has been a cluster of super cluster of galaxies called as Saraswati. So that super cluster galaxy was actually discovered by or confirmed by Astrosat. So that's why there have been many such observations that we have been able to make. Alright, moving on. Question number 12. Telios 2 and Luminite 4 belonging to which of the following nations were recently launched through PSLV by ISRO? This is the 12th question. You have 4 options: France, Japan, Singapore and Australia. So this is what it is. We are launching the poll for you. So please mark your answers here. There is again something crucial that I want to discuss with you. Please mark your answers. Alright, so as I see, many of you have already marked it. Fine. So let's have a discussion here. So now, when it comes to these two satellites, this question, seemingly a very factual question, right? You might think that, okay, this is fine, this is a very factual question. But I'll say no, it's not a very factual question. That first of all, this is, these are two satellites that were launched, one of which is a satellite which is based on synthetic aperture radar. So this satellite, for example, this is a synthetic aperture radar satellite. And the second one that you see here, the second one basically is a kind of a nano satellite. Now, both of them actually India has launched for Singapore with the help of PSLV C55. Now, so fine, factual question, but also look at the other options that you have. First is France. France has a very good set of launch vehicles. Alright, so even we go to France when we are not capable of launching our own satellites. We go to France and get the launches done. So chances are highly unlikely that France could be the correct answer. Same goes for Japan. It has a wonderful space agency, has been working on a lot of project on itself. So also it's very unlikely that Japan could be the answer, and same actually goes for Australia as well. So why I am saying this, why I am discussing this kind of a factual information, many a times there are chances that you are in a fix, that you have been able to, let's say, mark 40 questions or 50 questions and you need 20 extra. You need some 15-20 more questions to mark correctly. And this is where you many a times might have to take an intelligent guess. Not a random guess, an intelligent guess. So when you have to take an intelligent guess, this is where you try to eliminate the options. That even though, when you read the question, when you read the options, you might find that, okay, fine, this is a direct fact that they have asked. So if I know, I know. If I don't know, I don't know. But look at the options that you have. That if you had to take a guess, which country could it be? That let's say, apart from Singapore, one of the other options would have been another country which does not have a very good space agency of itself. Then perhaps it becomes a very difficult question. Then after that becomes very difficult to eliminate the options. But when you have the other three countries which have a very good functional space agencies of their own, it is where you can perhaps take a guess. And this time, that's why a guess, if I had to take a guess, the guess would be Singapore anyway. Alright, moving on. 13th question. With reference to small satellite launch vehicle, that is SSLV, consider the following statements. First, it successfully placed satellites into their intended orbit in its first attempt in 2022. It can carry a payload of 1000 kg to low Earth orbit. So these are the two statements given. We are launching the poll for you. Please mark your answers. Alright, so this time I see that there is a fight in A, B, C, D, that almost it's equally divided into A, B, C and D. Again, try to understand the statement on their merit. Fine. So I think many of you have marked it. So let's have a discussion on it now. So first and foremost, with reference to small satellite launch vehicle, that is SSLV, consider the following statements. First is, successfully placed satellites into their intended orbits in its first attempt in 2022. See, the first operational attempt was made in 2022, but it was not completely successful. The launch was successful, but placing the satellite into the orbit was not successful. It was intended to be a circular orbit, but because of some minor errors in maybe calculation or computation, we found that instead of placing in the circular orbit, the launch vehicle placed the satellite into an elliptical orbit. So that was the mistake that happened. So that's why it could not successfully place the satellite into the intended orbit. So that is what happened. So that's why this statement is not correct, that it did not launch its first, or it did not place its first satellite successfully into the intended orbit. Instead of that, what happened is, so it was supposed to be circular orbit, but instead of placing it in the circular orbit, it was placed in an elliptical orbit. So that was the mistake that happened. That was a slight problem that happened. So that's why this is wrong. Now, the second statement says it can carry payload of 1000 kg to low Earth orbit. Now, the name of the launch vehicle says small satellite launch vehicle. Generally speaking, when we say that something is a small satellite, alright, when we say that something is a small satellite, we mean that these should be satellites. Generally speaking, these are satellites which are less than 500 kg. These are satellites which are less than 500 kg. And in this also there are multiple different types of satellites. There are, according to ISRO, the classification that has been done by ISRO, these small satellites, there are 4 different types. They can be mini, they can be micro, they can be nano, and they can be pico. These are the 4 different categories of small satellites according to ISRO. So where when we talk about these small satellites, mini satellites generally speaking will be the satellites which are in the range of 100 to 500 kg. Micro satellites generally speaking, again there, I mean, because there can be slight variations in the nomenclature as well. So it will be in the 25 to 100 kg bracket. 1 to 25 is nano, and less than 1 kg is pico. Alright, so small satellite launch vehicle is meant for this class of satellites, which are small satellites where the mass is less. So 1000 kg is very high. Alright, so that's why it will not launch any satellite which has a payload of up to 1000 kg. So that's why the second statement also is wrong. So correct answer, that's why will be D, that neither 1 nor 2, both basically are wrong. Now understand this. Alright, understand this, that when it comes to these satellites, why exactly was this launch vehicle required? Alright, so first and foremost, when it comes to the launch of small satellites, very often you'll see that the small satellites will be clubbed with a bigger launch. That, for example, let's say when a PSLV launch is supposed to happen, then with that PSLV launch, which would already be weighing, let's say, in the range of 500 to 700 kg, what we do is some of the smaller satellites are launched along with it. Just like when you go to buy some vegetables, you also ask for some coriander for free. So something similar happens here, that some of these smaller satellites which are in the range of 1 kg to 5 kg to 10, maybe perhaps 20 kg, they will also be launched along with these bigger satellites. So what happens is that these smaller satellites or these smaller launches, they always have to wait for the bigger launch. That is one big problem that we face here. So that's why what we have tried as a part of this small satellite launch vehicle is that let these small satellites occupy the space of their own. That for all the smaller launches, for all the satellites which weigh in the range of, let's say, 1 kg, 5 kg, 10, 20, perhaps 30 kg, let them have their own satellite launch vehicle, and any small satellite launch, any small satellite being launched can be launched with the help of these satellite launch vehicles. And with this thought, ISRO basically started working on the small satellite launch vehicles. So small satellite launch vehicles, that's why they are important from that perspective. Until now, there are 2 operational launches that we have done. One was done last year, I think it was August 2022 when we did this launch. The second launch was this year, that is February 2023. So in this case, the second launch has been perfectly successful. The first launch, the launch was successful, but placing the satellite into the orbit was not. So that is where we erred a bit, and because of which we could not place it into the actual required orbit. So that's why remember this. And again, this year SSLV is going to be very, very important. Apart from SSLV, all the related topics, SSLV, apart from that, NSIL, New Space India Limited, will be very, very important. Apart from that, In Space will be very, very important. All these, because they are working simultaneously, they all together will be very, very important for your examination, because they have been carrying a lot of work, they have been doing a lot of work, they have been often in the news for one reason or the other, they are very often being talked about by ISRO wherever they are talking about. So that's why all these 3 terms, SSLV, NSIL and In Space. SSLV being the small satellite launch vehicle, NSIL being, you can say, the unit that is also trying to manage the operations of SSLV and looking after all the private dealings of ISRO. At the same time, In Space, which is also looking after the private companies and how the private companies might interact with ISRO and carry on a lot of different work. So that's why all these will become very, very crucial from examination perspective. All right, moving on, question number 14. Consider the following with respect to Gagan. It was jointly developed by ISRO and Airports Authority of India. It helps correct GPS navigation errors to provide accurate details per the standard of ICAO. And then Gagan can also be used in railway signaling and forest management. So 3 statements given to you. Please look at the statements. We are launching the poll for you. Please mark your answer, and then we shall have a discussion on this as well. All right. So as I see, many of you have marked your answers. So let's begin. So we are talking about Gagan. All right. So when it comes to the Gagan system, what exactly is this Gagan system? It is called as GPS aided geo augmented navigation. So that's why GAGAN, Gagan. Alright. So when it comes to this Gagan system, this is a system which is required or which has been built by India for helping the civil aviation in the country. Now, how exactly is it going to help civil aviation? Just understand a couple of basic points again here. First of all, we are trying to reduce the total flight length, total path length of any given satellite. Alright. So for example, any given, not satellite, any civil aviation or any domestic aircraft, any civil aircraft. Now, so first and foremost, when it comes to this Gagan system, what we basically are looking at is that this Gagan system will help civil aviation reduce the total flight path, because ultimately what happens is that while the flight takes off from one city to another, it actually does not take a straight line path. Anyway, it cannot take a straight line path because of some geographical reasons as well. For example, even the rotation of the earth also plays a role here, why it cannot take a straight line path. So it tries to take a path, but what we say is that the total distance that it covers is much larger than the actual distance that should have been. So that's why, because of that, the total flight length, the total path length is very large. Because of that, it also means that it is going to take more time to take you to the destination. Also, the fuel requirements will be larger, correct? It will need more fuel, and because it is needing more fuel, the cost also becomes a factor. You are using more fuel means that you are also spending more money on it. Not only that, the environmental factor as well. It is not good for the environment because of that. So that is why when it comes to the Gagan system will try to reduce the path length, and because of that there will be other important applications also that we will see because of that. So that is basically what we are trying through this Gagan system. So this Gagan system, as you can see in the picture itself, that there are two. One, the Gagan is being helped by the GPS, and the GSAT satellites are also going to help it. And with the help of these GSAT satellites, we are trying to reduce the errors that are caused by GPS or caused in the GPS system, because there are some ionospheric disturbances because of which the GPS system does not give us a very accurate result. So to make up for those errors, there are additional GSAT satellites also being used, which are also going to provide the information to this Gagan system. So let's look at the statements now. The first one is jointly developed by ISRO and Airports Authority of India. This is perfectly correct. These are the two organizations which have collaborated together to come forward with this Gagan system. So that's why this is correct. The second statement is it helps correct GPS navigation errors to provide accurate details per the standards of ICAO. ICAO is International Civil Aviation Organization. So when we talk about this GPS navigation errors, this basically happens because of some ionospheric disturbances. Alright, ionospheric disturbances, because of which it is being used. So that's why this is correct, that it helps to correct that with the help of some additional machinery, like for example the GSAT satellites, which are also being used. And then after that the third one says Gagan can also be used in railway signaling and forest management. This is also correct, because when it comes to the Gagan system, the primary objective, the primary function is to help civil aviation. That's fine, that it's going to help civil aviation. But It's not going to help only civil aviation. It's also going to help in railway signaling. It is also going to help in roadway transport. Even in traffic management, it is going to help. At the same time, in managing the waterways also, it is going to help. It is also going to help in geological studies. It is also going to help in many of the other activities as well. So that's why it's not only that it is going to help in civil aviation. Let's say one of these statements in your prelims examination says this, that it is a system which is supposed to help only the civil aviation in the country. That's wrong. It's not only about the civil aviation. The primary objective, yes, is civil aviation, but it is also going to help in other activities as well. So that's why we see that in this particular case, all these three statements given here, all these statements are correct. So correct answer, that's why here will be D. That is, all the three statements 1, 2 and 3 are correct. Moving on. Question number 15, something that has been in the controversy on and off. According to the Indian Patents Act 1970, which of the following is not considered an invention? 1. A new product. 2. A new process. 3. Mere discovery of a new form or property of a known substance. And 4th, if it does not significantly enhance the efficacy of the substance. So these are the 4 statements given. Alright, so please read them and please mark your answers, and then let's have a discussion on it. So I'll give you some more time, some extra time, so that you can go through everything. All right, so let's begin with the discussion. So, according to the Indian Patents Act 1970, which of the following is not considered an invention? So, not considered invention. Now, when it comes to not being considered as invention, just understand few of the basic points here. That what exactly do we not consider as invention? So, first of all, a new product. A new product will always be considered as an invention. So that's why there is no problem here. Yes, there are exceptions to it, and those exceptions are what we are going to discuss here. So a new product, yes, it will be considered as an invention. A new process will also be called as an invention. So that also there is no problem here, that it will be also considered as an invention. Now understand these two, fine, that these two will be considered an invention. Now coming to the third statement, mere discovery of a new form or property of a known substance. Now this is something that is not considered as an invention. We have a section in this act, the section 3. And this section 3 basically deals with the basic ideas or the basic ways in which something will not be considered as a part of the patent or something that can't be patented in India. So there are a lot of things that has been considered here, and there is a specific section called as the section 3D of the Indian Patents Act, which basically looks after these kind of problems. That many a times what happens is that when it comes to the pharmaceutical companies specifically, we see that many a times pharmaceutical companies will always be looking for extending the patents that they already have. So let's say they have a drug in the market and the drug has a patent. Alright, the drug has a patent, and because of that drug having a patent, what we see is that they very often gain a lot. Financially they gain a lot, so they want to continue with the patent for as long as they can. So what they do is that if let's say the patent is about to expire, or if the patent has already run its course, what they'll do is that they will make some small changes. Alright, some small change in the product, some small change in the process, and they'll say that look, because of this change, now there are some properties that change. There are some better properties that we see altogether in this. So I need an extension to this patent. This is something which is also called as patent evergreening. Patent evergreening. So this patent evergreening is that many of the pharmaceutical companies very often try to do. Now this section 3D tries to save India or people of India against patent evergreening by many of these companies, and that is why it has been so much in controversy, that many of the American companies and the European companies, they want India to remove these kind of sections because it becomes very difficult for them to keep getting those patents in India. So that becomes very difficult for them, and that's why they don't really like these kind of sections. So that's why they often has been in the news and they have been in controversy, especially with regards to what we see in India and how India treats its patents. So that's why just discovery of a new form or new property of a known substance can't be patented. Similarly, if it does not significantly enhance the efficacy of the substance, you cannot patent it. That if you want to get it patented, the only thing that you have to do is that what you have to basically do is that you have to show that there is a significant change or a significant improvement that you are able to bring in when it comes to this kind of patenting, and then only you will be allowed to get that patent. Alright, so that's why this is in these two cases, these two are not allowed, and these two are basically considered as a part of section 3D. So section 3D prohibits you from doing this. So that's why section 3 altogether will take care of everything related to these kind of patents. For example, let's say section 3A talks about that anything that is going to be harmful for humanity cannot be patented. That you cannot bring out a new kind of a gun and say that this is what will destroy the entire humanity and I want to get it patented. You can't. In India at least you can't. And that is what section 3A is. So similarly, you have all these parts of this section 3 that takes care of everything related to what cannot be patented in India. Alright, so this is basically what we see, correct? So that's why 3 and 4 wrong. So you have been asked to mark what is not considered. So 3 and 4 both are not considered. So correct answer will be D. Alright, correct answer here will be D. Moving on. Question number 16. Consider the following statements concerning the first Center of Excellence set up recently in the Northeast. First, the Center for Bioresources and Sustainable Development has been declared as the COE or Center of Excellence, and it is located in Arunachal Pradesh. These are the two statements given. Now, please mark your answers. We are launching the poll for you. Please mark your answers, and then after that, let's have a discussion on this. Alright, so let's start the discussion. This could be a topic that you perhaps would have not heard of, but still I would say it remains an important topic. Now, when it comes to setting up of Center of Excellence in Northeast, yes, it has been done in Arunachal Pradesh. There is a place called as Kimin, and this place Kimin is where it has been set up. So now when it comes to this, yes, it has been set up, and Center for Bioresources and Sustainable Development has been declared. This is also correct, that this has been done by the Department of Biotechnology. The Department of Biotechnology has done it, and they have basically declared this as the Center of Excellence. So both the statements given here, both the statements are actually correct. Now also understand the context, that why exactly this question. There are two new patents that have been given to a scientist in Arunachal Pradesh, and these two new patents that have been given, both are related to the diabetes. Some of the new discoveries, some of the new developments that he has done with the for diabetes, which will help in the treatment of the painful diabetic neuropathy. So in this case, we see that there are two such patents that have been given in his name. So what will happen, let's say if they have to ask a question apart from, let's say, something related to these organizations, if they have to ask you a question, they would directly name the patent. There are 2 patents that goes in his name. They will simply name that patent and they'll simply ask you what is it exactly related to. So alright, so for example, there is a new herbal method for the treatment of the painful diabetic neuropathy is one of those patents that has been given. And then there is a herbal cotton patch that he has basically made, and for these 2 he has been given the patent. So that's why these 2 would perhaps be named. If they have to give a question based on this, these 2 perhaps be named and they would ask you what exactly is it related to. So it's related to the 2 patents that has been given in this particular regard. So both the statements given here, both the statements are correct. Moving on to the last 2 questions, which are based on generative artificial intelligence. So the first question, question number 17. Which of the following statements is not true regarding generative AI? One, or first statement, generative AI is a type of artificial intelligence that can create a wide variety of data such as images, videos, audio, text and 3D models. It can produce highly realistic and complex content that mimics human creativity. Third, completely eliminates the problem of deepfakes. And fourth, with generative AI has also been used to create chatbots and virtual assistants that can converse. Alright, so what is not true has been asked. So converse with humans with a more natural and intuitive way. So poll has been launched for you. Please mark your answers. This is an easier question, I would say, compared to many of the other questions that we have seen. All right. So I see the responses. Ending the poll now. So as I see, I mean 90% of you have marked C. So I'll go with the audience, as they say in KBC. I'll go with the audience. The correct answer, of course, is C. So what we are talking about here is that what is not true about generative AI. So first and foremost, what do we mean by generative AI? So generative AI basically is a kind of an AI. Generative AI is a kind of an AI or an artificial intelligence that can generate content. Until now, what we know about AI is that it can understand patterns and it can give you information based on those patterns. Now what we are seeing is that they can now also create content based on that pattern. And how did it all become so popular all of a sudden? Popular or not, famous, let's say. Famous is a better word, because of ChatGPT, right? That all of a sudden, November 2022, ChatGPT was introduced, and then after that we saw that so much of discussion around generative AI all of a sudden started. That what all this can do and what exactly this can do, and how the positives and the negatives both are being discussed. That we are talking about the problems that it can lead to, the job losses that it can lead to. There are so many problems that we are talking about, and at the same time we now see the next step of what AI can do. Until now we just saw that it was good in reading your content, it was good in reading the pattern, but now we see that this is where it is going to the next level, where it can not only do that, not only read the content, but also write or make the content for you. So that is what it is. So first statement basically is that the first statement, in a manner you can say, is the definition of generative AI, that it's a type of artificial intelligence that can create a wide variety of data such as images, videos, audio, text and 3D models. So that's why first statement is correct. It's like the definition itself. Second statement, can produce highly realistic and complex content that mimics human creativity. This is also correct, and this is what we are seeing now, that it is able to do a lot of work that often will be done by humans. So that is why we are talking about so many job losses. Third is, can completely, or it completely eliminates the problem of deepfakes. It actually creates a problem of deepfakes. You might have seen this video about Barack Obama and how the words were being put in the mouth of Barack Obama, that he is, for example, he's not saying this. I mean, this, the one where you see our result, this is not something that he is saying, but something that deep fake, a kind of an artificial intelligence, deep fake, has actually produced something like this. So we cannot say that it is eliminating the problem of deepfake. It is actually creating the problem of deepfake. That this was one of the earliest examples where the world was introduced to what something like this could do, and that's why we see that this is what is happening. So basically what they did is that they took the original speech that was being given by Barack Obama, and the words were pulled out of it, his facial expressions were pulled out of it, and the second one that you see here, the second one is a fake video where what you see how the lip movement is happening is not the original lip movement, but rather a lip movement that was created by artificial intelligence. So it was done with the help of something called as deepfake, done with Barack Obama, again done with Vladimir Putin as well, and after that we have seen it that something like this can be done. So that's why we understand that this is something that can be done by generative AI. So that's why absolutely this is wrong. It does not eliminate the problem, but rather creates the problem. And then that's why the C is wrong. So anyway, this is what you had to pick, that you have been asked to pick what is not true about generative AI. So that's why this fourth statement given here is also correct. So correct answer will be C, because you have to pick what is not correct. Moving on. The last question for the day. Which of the following popular generative AI tools is not correctly matched? First is GPT, that is Generative Pre-trained Transformer Natural Language Generation Task. Second is StyleGen, used for research and experimentation due to its high computational requirements. Then you have CycleGen, widely used tool for image-to-image translation task, and DALL-E for generating image from textual descriptions. Alright, so launching the poll for you, please mark it, and then we shall have a discussion on it. Alright, so ending the poll now. Let's have a discussion on it. Fine. So these are the four statements given to you. First is GPT. Now GPT, I'm sure that you have heard of Chat GPT, right? Is there anyone who has not heard of Chat GPT here? Chat GPT, I'm sure that you have heard of. Otherwise, you're not reading current affairs. You are living under a rock if you have not heard of Chat GPT yet. So Chat GPT, we know it is related to language. It is related to text, that where we are trying to create text-based content, or AI will be able to create text-based content. So that's why this is correct. Alright, so first is correct. Now for second, third and fourth, look at these three images that you see here. Now when you look at these three images, the first one that is StyleGen, this is also related to images. Alright, this is also related to images where you are trying to create different versions of a face. Whereas when it comes to CycleGen, this is something that is used for image to image translation task. So for example, if you see this, what you see is that input was basically a horse and the output was supposed to be an exact replica of this horse in terms of zebra. So this is something that has been done, and overall this is something that CycleGen can actually do for you. Alright, this is what CycleGen can also can do for you. So this is something that has been created from that you took an input image of a horse and this was to be transformed into a zebra, and they have been able to do that. So as you can see that perfectly they have been able to create this. Alright, so this is basically what has been done. Then this other image that you see is basically of DALL-E, where what you do is that you give an input to the AI that I want this kind of an image. Alright, so for example, I want an image of me sitting in the examination hall and solving all the problems very happily in the prelims examination. You give this kind of a description and the AI will be able to pull out an image which is exactly this. So this is what DALL-E can basically do. That if, let's say for example, if you have asked the DALL-E to create that, okay, let Da Vinci been shown in the picture painting this Mona Lisa, with Mona Lisa also sitting in the same frame. This is the image that it will be able to produce for you. So it is able to do all that. Whatever kind of image you want a scenery. I want a scenery where I am sitting by the side of a hill on a mountainous region, having Maggie maybe perhaps there. So all this can be done with a Dolly. And then after that, this is what Style Jan can do, and I'm sure you might have seen this, that aged version or childhood version of any given person or any given image can be formed with the help of this. So now, why this question I have given you, more important than what has been given, why this question? Because today we see that generative AI is in the news, chat GPT is in the news, and because of that the various different types of the generative AI which is right now available, they are in the news. So all the major, there are many, so you can't remember all of them, the major generative AI, they can become important for you. That's why this kind of a match the following question we have given to you, so that you understand that, okay, these are the ways that you have to remember them, that these are some of the key, the most important ones, which have been in the news or which are being used by, let's say, in the industries or maybe people at large. They all become very, very important for you. So that's why from that perspective, look at this question, and it's not only about these 4 names that have been mentioned in this question. All right. So overall, what we see here is that artificial intelligence, specifically generative artificial intelligence, this AS Prelims examination is going to be very, very important. All right. So this is it. These are the questions that we had for today's session. I hope that these sessions help you understand the topics more than just the questions, that these are the topics to revise, these are the questions, these are the topics which we believe could be the most important ones from the field of science and technology. So please go back, revise everything. We'll be back again tomorrow with new set of topics, some of the other key areas from the perspective of your prelims examination. Until then, we'll meet again tomorrow, same time as we did today. Until then, good night.